Hi everyone, welcome to Lecture 21 on Basic Inorganic Chemistry. My name is Dr. Teresa Chimambam. Right, today we will learn how to calculate moles from balanced chemical equations. Okay, the mole ratios in a chemical equation are very important in calculating moles from balanced chemical equation. If you are asked to calculate the mass of a product produced from a reactant, you need to follow three steps. The first step is to convert the mass of the reactant that you are given in the question to moles. The second step is to convert the moles of reactant that you obtained in step 1 to moles of product. And you do that using the mole ratio from the balanced chemical equation. The last step is to convert the moles of product that you obtained in step 2 to mass of product. So in summary, if you are asked to calculate the number of moles from the balanced chemical equation, you follow three steps. So the first thing is to convert mass of reactant to moles of reactant. And then the second step is to convert the moles of reactant to moles of product. And then the last step is to convert the moles of product to mass of product. So these are the steps that you need to follow whenever you are calculating moles from balanced chemical equation. So let's look at this practice example. You are given this balanced chemical equation, assuming that you use 1.37 gram H2 in the laboratory. How many grams of HCl can be generated? So the first step is to convert mass of the reactant, which is 1.37 gram, to moles. And to do that, we use the formula for moles, which is equal to mass divided by molecular weight. So the mass is 1.37 gram, which is given. We divide that by the molecular weight for H2, which is 2 times 1.008 gram per mole. This 1.008 is the molecular weight for hydrogen, and you find this in the periodic table. We multiply it by 2 because of H2 here. So this will give us 0.680 mole used in the experiment. So this gram, we cancel this gram, and this mole comes up. That's why our final unit is in mole. So we have now converted the mass of reactant, 1.37 gram, to moles. The second step is to convert the moles of the reactant to moles of the product using the mole ratio from the balanced equation. So in the equation, 1 mole of hydrogen gas produces 2 moles of HCl. 0.680 mole that we calculated here produces S. So you need to find this S. If you do cross multiplication here, S will be equal to 0.680 multiplied by 2. And this will be equal to 1.36 moles of HCl produced. So now we have converted the moles of reactants to moles of product. The last step is to convert moles of product to mass of product. And we do this using the formula number of moles equal to weight divided by molecular weight. If we do cross multiplication here, we will get that weight is equal to number of moles multiplied by molecular weight. So we obtain this by doing cross multiplication here. We calculated moles of HCl in the previous slide to be 1.36 moles. So we put this value here for number of moles and we multiply by molecular weight for HCl, which is 1.008 plus 35.45 gram per moles. So this 35.45 gram is the molecular weight for chlorine and 1.008 gram per mole is the molecular weight for hydrogen. You find these molecular weights in the periodic table. So these moles, we cancel these moles. If you add these two and multiply by 1.36, you will get 49.58 gram. So our final unit is in gram because these moles has cancelled these moles. So it means then that 1.37 gram of H2 that we are given in the question gives 49.58 gram of HCl. So this is our final answer. Okay, let's look at another example. If 3.42 gram of ammonia reacts completely with excess oxygen, what mass of water can be obtained? This is the balanced equation for the reaction. So step 1 is to convert the given mass, which is 3.42 gram of ammonia, to moles. So you need to convert the given mass of reactant to moles. So the molecular weight of ammonia is 17 gram per mole. So if you add the molecular weight for nitrogen and 3 atoms of hydrogen, it will give 17 gram per mole because the molecular weight for nitrogen is 14 and molecular weight for hydrogen is 1. So 1 times 3 is 3 plus 14 is equal to 17 gram per mole. So this is the molecular weight for ammonia. So this implies that 1 mole of ammonia weighs 17 gram because molecular weight of ammonia is 17 gram per mole. S mole of ammonia weighs 3.42 grams. So we don't know how many moles that 3.42 gram will weigh. So to do this, to solve for this S, we do cross multiplication. So this S will multiply 17 gram and it will be equal to 1 mole multiplied by 3.42 gram. So if we make S the subject of the formula, we will have that S is equal to 3.42 gram divided by 17 gram. So this gram will cancel this gram and we will get 0.201 mole ammonia. So this is how to convert the given mass of reactant to moles. So now that we have converted mass of ammonia to moles of ammonia, we now go to the second step. The second step is to convert the moles of reactant to moles of product using the mole ratio from the balanced equation. So this is the balanced equation. So we need to convert moles of ammonia to moles of water. According to the balanced equation, according to this equation, 6 moles of water can be obtained from 4 moles of ammonia. So 4 moles of ammonia gives 6 moles of water. So 0.201 mole ammonia, which is the mole that we calculated in the first step, multiply by 6 moles of water, because we have it here from the balanced equation, divided by 4 moles of ammonia. This is also from the balanced equation. So these moles of ammonia, we cancel these moles of ammonia. So if we multiply 0.201 by 6 and divide by 4, we will get 0.302 moles of water. So it means that 0.302 moles of water can be produced. So now we go to the last step. Okay, the last step is to convert moles of products to mass of products. And we do this using the formula number of moles equal to weight divided by molecular weight. If we do cross multiplication here, we will get that weight is equal to number of moles multiplied by molecular weight. So we obtain this by doing cross multiplication here. So simply doing cross multiplication here, we will get that weight is equal to number of moles multiplied by molecular weight. The molecular weight for water is 18 gram per mole. So this 18 gram per mole is the molecular weight for water. So oxygen has molecular weight 16, hydrogen has molecular weight 1. So 1 multiplied by 2 is equal to 2 plus 16 for oxygen gives us 18 gram per mole. So this 18 gram per mole is the molecular weight for water. 0.302 moles of water was calculated in the previous slide. So weight of water is equal to, we put this 0.302 moles in place of number of moles, we put it here, multiply by molecular weight for water, which is 18 gram per mole. So I've written the gram per mole in this form so that units can cancel out. So in this way, this mole cancels this mole. If you multiply 0.302 by 18, you will get 5.436 grams. So gram is our final unit because that's the only unit remaining. This mole has already cancelled this mole. So it means that 3.42 grams of ammonia gives 5.436 grams of water. So this is our final answer. Right, so this is where I'm gonna end for today's lecture. Please like this video and subscribe, and I will see you in the next lecture.